All right, so remember we're only dealing with the real number system, and we already kind of talked about one restriction. One restriction in the real number system is you can't take the square root of any negative number ever. You got one more restriction, only one more, and the restriction has to do with fractions. That's not a fraction, but just think in your head about a fraction. There's only one number in the entire universe that cannot be below a fraction bar. Do y'all remember what cannot be below a fraction bar? It can be a positive number, it can be a negative number, it can be an exponent, it can be a decimal. There's only one number that can never, ever, ever be under a fraction bar. Like, it's impossible. 0 is correct. Good job. Or whoever said that. Yes, yes, yes. So there's two restrictions. No negative roots, no zeros in the denominator. Y'all look at this right here. Do you see a square root symbol? No. So we don't have to worry about that restriction. Do you see a fraction bar? Nope. Don't have to worry about that restriction. So we automatically know that negative to positive infinity is going to be the domain for that. So let's write negative to positive infinity. And then for the range, y'all, the first week of school, I'm not going to ask. You can calculate the range algebraically by converting it to vertex form. I'll just show you the graph. I already put it in Desmos for us. So there it is. No surprises, it goes on forever, both to the left and to the right, but it does not go down forever. The lowest value is right there, that is that vertex. So when we write the range, do you guys remember which coordinate we used from this for the range? The y coordinate, very good. So on your range blank, go ahead and start writing, well, you're not gonna write the y coordinate first. What are you gonna draw first? A bracket. Good job. So this is going to be a bracket of negative 1.125 all the way up to infinity, because it does open forever. Let me get caught up with you guys. Negative 1.125 all the way up forever. And then we're going to review just, when is the bell ring? 45? Okay, we're almost done. We're going to review order of operations, y'all, because you've got to be good on your order of operations here. Let's go ahead and plug in a 3 into this function and evaluate it. So this is going to be g of 3, and it is going to be 2 times 3 squared minus 3 times 3. All right. So, as you can see here, we are ready to roll, and we've got to remember our order of operations. Your order of operations really start with parentheses, and we do have parentheses up here, but y'all, there's nothing, like I don't need to add or subtract any parentheses. What do you do after parentheses? Exponents, I think I heard that. I don't know who said it, but you are right. Don't do 2 times 3. No. You got to get rid of your exponent first. Okay, so this is actually going to be 2 times 9. And then, of course, a negative 3 times the positive 3 is a negative 9. So the answer is just going to be 18 minus 9, which is 9. Look how I wrote that. I wrote the input in parentheses. I wrote the output on the other side. And before we continue, guys, I made a big mistake. I'm so mad. Over here on problem 4, can you please just cross out even, odd, or neither? That is such a teacher fail. Please cross that out. I'll explain why in a moment, but just cross it out for now. Let's go back to problem 2. So for problem 2, we are going to evaluate that function with the opposite input. So let's go ahead and drop in a negative x where we see a positive x. So this is going to be g of negative x. And that is going to equal, I want to make sure you see all this, 2 times negative x squared minus 3 times negative x. Now, let's evaluate. What happens when you square a negative number? What does it turn into? It turns into a positive. So g of negative x equals 2x squared plus 3x. Guys, look over here in green. Up here, we need to get pretty familiar with that. We're going to figure out if this is an even, odd, or even. I know it's an even if I have the same exact answer that's printed on the paper. Y'all, look at what's printed at the top of the paper. Does this match this exactly? No, then it's not even. Is it odd? If I have an opposite input, then I should get the exact opposite output. Here's what's printed. Is this exactly opposite? No, then it's neither, right? Neither on the line. And guys, that should just kind of also connect with what's graphed over here. Guys, if y'all notice, this parabola is over here floating on the right side. Most even and odd functions are kind of symmetrical right in the center of the coordinate grid. So all of that is why it is not symmetrical. All right, so let me go ahead and pause.